Hi all. Today we'll be discussing the LeetCode problem of the day, smallest subtree with all the deepest nodes. So here you're given root of binary tree and the depth of each node is the shortest distance to the root. So if we have this 3 is the root, so depth of this node from the root will be 0 and depth of the node 5 from the root will be 1. Similarly 1 for this, and for all these nodes the depth will be 2, and for the last two nodes we have the depth as 3. So you can see 1, 2, 3. So node 4 is at depth 3 from the root. So now you have to return the smallest subtree such that it contains all the deepest nodes in the original tree. So this is the original tree, and in that we can see we have the deepest level is 3 and we have two deepest nodes, which is node 7 and node 4. So in the question he asks you to return the smallest subtree which that should contain all the deepest nodes. So if we see 5, if we see the subtree of the 5, this is the subtree which is at the root 5. So in this we can see that this subtree contains both 7 and 4. But you have to return the smallest subtree that contains all the deepest nodes. So instead of 5, if you take 2, so the subtree with root 2 will be this one. So this has all the deepest nodes, which is 7 and 4, and this is the smallest subtree you can possibly find. So this is your answer. So for this case, you will return the subtree which is at root 2. So the answer will be 2, 7, and 4. So instead, if you have another node here, maybe you have 8. So now this is also at depth 3. So in this case, you have to return 5, because if you return 2, the subtree will only contain 7 and 4, but it should also contain 8 because 8 is also a deepest node. So if you return 5 in this case, so subtree at 5 will contain all the deepest nodes, which is 8, 7, and 4. So if this is the case, then you have to return 5 as the root. Now let's say you have another node here, which is say 9. And this is at also at depth 3. So now in this case, you have to return the smallest subtree, which should contain 7, 4, and 9. So the only possible node we can return is the node 3. So that means this entire subtree will contain 7, 4, and 9. So if you take any other subtree, then either you will miss 9, or if you take this subtree, you will miss these both nodes. So for this case, the answer will be 3. So now let's look at the second example. So here you have only one node, and this is the deepest node in the tree. So this is what you'll return. The answer will be 1. And the third example, you have 0, then 1, then 3, then left is null, and right is 2. So in this case, 2 is the deepest node. So you can directly return the 2. In case there was some other value here, then 4 is also deepest node. So you have to return a subtree which contains both 4 and 2. So in that case, you will return this 1. So in this case, 1 will be your answer. But since you don't have anything in the left and 2 is the only deepest node, so you can simply return 2 itself. Now coming to the constraints, the number of nodes in the tree will range from 1 to 500, and the values in the tree will range from 0 to 500. It is given that all the values in the nodes, all the values in the tree are unique. Now let's go with the approach. So we'll also be writing the code alongside discussing the approach. So suppose we want to find the maximum depth of each subtree. So for this entire tree, the maximum depth is 4. So a subtree with root 3 has a maximum depth 4. And for the subtree at root 1, the maximum depth will be 2. Because in this subtree, you have level 1, depth 1 and depth 2. And similarly for this one, you will have a depth 3. Because at this 5, you have 3 nodes with root as 5. And here you will have depth 1, depth 1. These all will be of depth 1 because they are the leaves. And here for this subtree, the maximum depth will be 2. So to find this depth configuration, suppose you don't have the depth 4. Now you want to find for this root what is the maximum depth of the tree. So for that, you will look at the left subtree and see what is the maximum depth, which is 3. And you look at the right subtree and it has a maximum depth 2. So depth for this original tree will be the max of the left subtree and right subtree plus 1. So max of 3 and 2 is 3. So to that you'll add a plus 1. So you will get the depth as 4. So you can see that depth 4 is obtained by going along this path. So the plus 1 you added is this, and this original 3 is all these 3 nodes. Now similarly, suppose you don't know this too. You want to find the depth of the subtree at root 1. So for that, first you'll try to find the depth of the left subtree, which is 1, and the depth of the right subtree, which is 1. So max of 1 and 1 is 1. So to that, you'll add a plus 1. So you'll get the depth as 2. So if you want to find the depth of the leaf node, for that as well, it's the same thing. You'll try to find depth of the left subtree and the right subtree. Since left subtree is null and the right subtree is null, the depth will be 0 here. So max of 0 and 0 will be 0. So to that, you'll add a 1. So the depth of 8 will be 1. So clearly we can see that, suppose again for 4, if you want to find the depth of this node 3, first you need to get the depth of the left subtree and you want to get the depth of the right subtree. So this is clearly a recursion, more formally a post-node traversal, to get the depth of the current node based on the depths of left subtree and right subtree. So let's quickly write a function to get the depth. So let's say DFS. So the return type will be depth. So the first case, if the root is null, then you don't have any depth. So if root will be null, you will directly return 0. So after that, like we discussed, you are at 3. You want to get the left sum. Also, you want to get the right sum. So for that, you can again call the DFS. So left will be DFS of root dot left, and right will be DFS of root dot right. So when you're at 3, left will currently contain the value 3 because the depth of the left subtree is 3. Similarly, right will contain 2. So now you just want to return the depth of the current tree. So you will just return 1 plus math.max left comma right. So this is how you will calculate the depth of a current depth of your entire tree. So instead of using the math.max, let me just expand this. So let me say if left equal to right, then I will return. So math.max of left and right is anything. It's either left or either right because both are same. So I can let me use left. Let me say 1 plus left. And if left is greater than right, then we will return 1 plus left. So in this case, left is greater than right. So you're returning 1 plus left, which is 1 plus 3, which is 4. So we can use else if here. And the last case, again, else if right is greater than left, then you'll return 1 plus right. So I'm just expanding what we are writing in the math.max. So you'll see why this is useful. Okay. So at this point, when you're at 3, you see that left subtree has a depth 3 and right subtree has a depth 2. So since in your original question, you want to find the all the deepest nodes. So the left subtree has a depth 3 and the right subtree has a depth 2. So since right subtree has a smaller depth, you are sure that you won't find your deepest nodes in your right subtree. So you can entirely ignore the right part. So now from your left part, you are at 5. Again at 5, you see that your left subtree has a depth 1 and your right subtree has a depth 2. So that means the left subtree will not contain your deepest nodes. So you will find your deepest nodes in the right subtree, which is in this. So now when you're at this node 2, you see that your left subtree is 1, depth is 1, and the depth of right subtree is also 1. That means your answer will be the current root, because this node will contain both the left subtree and the right subtree. So when you're at this 2, 2 is your answer, and this 2 you'll try to propagate it upwards. So what I mean is, so till now we are only returning the depth alongside, we are only returning the depth, and from the depth we are calculating the current depth, which is 4 here. But now along with depth, we will also try to return the node. So for that, let me use a different color. Okay. So first you are at 1. So 1 is the depth and the node is 6. So 6 is the actual answer here, because at 6, you see that left subtree is 0, right subtree distance depth is 0. So since both are 0, so 6 can be my deepest node. So here I'll return 1 comma 6. And similarly, here I'll return 1 comma 7. We use blue color. Green is not visible. Yeah. So here I'll return 1 comma 6. Here I'll return 1 comma 7. Here 1 comma 4. Similarly, for all the leaves, I'll return the leaf itself. 1 comma 8. So 1 denotes the depth and the blue 8 denotes the root. Now you're at 2. So at 2, you see that left has a distance 1 and right has distance 1. So both distances are equal. So at this, you will return the root, the current root, which is again 2. So that indicates the subtree at 2 will contain both 7 and 4, which is the maximum, which is in maximum depth. So at 2, you are returning 2 as the depth and the root also as a 2. Now you are at 3. So this is the important part. So here you see that the left depth is 1 and the right depth is 1. Right depth is 2. So since the left depth is smaller than the right subtree depth, you can completely ignore the left subtree. And the answer will be equal to the result of the right subtree, which is 2. So this 2 gets propagated upwards. So for the 5, you will return depth as 3 and the answer as 2. Now if we check for this 1, Here also, left subtree depth is 1 and the right subtree depth is 1. So in the current one, you will return 1 as the root. So far, this is the 1 is the subtree. If you assume 0 and 8 to be the largest depth. But when you are at this 4, you will again compare the depth of the left subtree and right subtree. So left subtree is of depth 3 and right subtree is depth 2. So you'll completely ignore the right subtree because it has the smaller depth and you will never find your deepest nodes in this right subtree. So since your left subtree has the deepest nodes, so this 2 will get propagated upwards. So when you're at 3, you will return 4 as the depth and 2 as the root. So when you call the DFS at root, which is 3, you will return 2 values. One is the depth, which is 4, and one is the root, which is 2. So in our example, 2 is the actual answer because at 2 is the smallest subtree, which contains both the 7, which is the largest depth, and 4, which is at the largest depth. So let's quickly turn our code to return the root alongside the depth and do the necessary modifications. So first thing, since you want to return both integer and tree node, for that you want to create a class. I will say pair. You have depth and tree node. So let me quickly write the constructor. B is equal to D not equal to N. So now instead of left will not return an int, it will return the pair. So I'll change the return type to pair. So in this case, this will return 3, 2. 2 is the node. And for the right subtree, it will return 2, 1. So left is DFS of root.left, right will be DFS of root.right. Now you want to compare the depth. So left.depth is equal to right.depth. Then you'll return 1 plus left.depth. So along with the depth, you also have to return the node. So in this case, you have to return the left dot node. So I can say return new pair. The depth will be 1 plus left dot depth, and the node you want to return will be left dot node. So in our example, when you do the left call, you see that okay, this is the equal case. Yeah, so this is the equal case. For this, the left will be 1, 0. This is the left, and right will be 1, 8. This is the right. So left depth equal to right depth. So you will return 1 plus left dot depth. So the depth will be 1 plus 1, which is 2. And the node you have to return will be the root only, which is 1. So at this recursion call, you will return node as 1 and the depth will be 2. Now the case where left is greater than right. So this is our original case for this route. So left depth is 3 and the right depth is 2. So in this case, we just copy this. The new depth will be 1 plus left dot depth, which is 1 plus 3, which is 4. And the root and the node will be the same as the node of the left one. So the same thing, you will propagate it upwards. So you can say left dot node. And similarly, you will do it for the right. but instead of left, you will have right. And since in the 3fs call, you are returning a pair and you want to return only the tree, only the root, so you'll return dfs of root dot node. So dfs of root will return this pair. So in that pair, you don't care about the depth, you only care about the node. So you are returning the node. And I think we also have to change the base case. New pair 0, and you can say null for this case. So for the new code, again, I quickly want to do a dry run. So let's see. First, you will get the left and the right. So it starts from 6. So at the 6, you call the left. So you hit the base case and you will return 0, null. So the distance is 0, the depth is 0. Same for the right, you get the depth as 0. So now you go to this case, left depth is equal to right depth. So you'll return 1 plus left depth, root. That means in this 6, you will return 1 as the depth and the root will be 6. The same thing can be applied for all the leaf values. So let me quickly write them. So here you will return 1, 7. Here 1, 4. Here 1, 0 and 1, 8. So now for 2, let's see what happens. So you're at the 2, you call the left subtree and you call the right subtree, and this is what the values you return. So here left dot depth is 1 and the right dot depth is 1. So if both are equal, then you'll simply the depth will be 1 plus 1, which is 2. So depth is 2 and the root will be the current root, which is second 2. So for 2 it's done. Now let's see for 5. So for 5, the left sum is 1, left depth is 1 and the right depth is 2. So this you'll go to the else if case. Else if right is greater than left, so you'll return new pair of 1 plus right dot depth. So depth will be 1 plus 2, which is 3. But here the node will be the right node. So the right node was 2. So this 2 got propagated upwards and the return value is 2 for this. Similarly for the 1, you have the left depth as 1, right depth as 1. So you'll go to the first if case and you'll just return depth plus 1. So depth will be 2 and the node will be the root, which is 1. Now finally, you arrive at 3 and you call the left subtree and you return 3, 2. And the right subtree, you receive 2, 1. So you see that left subtree depth is more. So you can safely ignore the right subtree. So you'll enter this case. Now new depth will be 1 plus left dot depth. So the new depth is 4 and the node will be the left dot node. So this 2, it's again getting propagated upwards. So the value will be 2 here. So that means when you originally called dfs of root, so you originally called dfs of 3 here, this returned you 4, 2, where 4 is the depth and 2 is the node. So since you're interested in only the node, you'll just return the return value dot node. Let me test now. Okay, dfs of root dot. Okay, I have to return this. And then here the class type is pair, not node. And then similarly, like we did left dot depth here, we have to do left dot depth. And for right, it should be right dot depth. Okay. Okay, since I'm using only if and else if, it is asking for an extra return here. So I can just change it to else. So it will fix that issue. Okay, let me submit now. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, we are performing a DFS, which will iterate on all possible nodes in the tree. So it will be order of n. And coming to space complexity, we are not using any arrays or such, but since we are doing a DFS, you will have a recursion stack and the space will be equal to the height of the tree, the deepest level of the tree. So for that space, we can just say order of height, where h is the height of the tree. In this case, the height is 4. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.